All right, let's go over the EDA assignment. So the first question that you are asked is you just are asked to write a paragraph that just explains the shape and content of this data set. So we've already imported the data set by running these two commands here. This setup that we always run just to get things initialized. And here we have now created the data set, and the data frame is called df. So we're just going to ask a couple questions about it. We want to know, for example, what is the shape of this? And we can see it's got 4,898 records, 13 columns. We want to know, well, okay, what kinds of things are in here? We have df info. And so we can see we have, first of all, there are no null values here except for color, in which there are no records, so that's not going to be helpful to us at all. And what we have are all these different chemical properties that describe at least the chemical properties of each of these different wines. And there are, again, 4,800 wines. Let's just take a look at the first couple records here and see what we see. So we can see we have a wine, and there's no information about the wine except some index number. So we don't know anything about the wine except its chemical properties. And we know something here about its quality. And the quality rating was something that was assigned to it by, people who do this sort of thing. Everything else was a chemical analysis. And so those are the things that you can look at when you are describing what's going on inside this. You're then asked to use df describe, and as you do that, you're going to get, for all the quantitative columns, you're going to get this quantitative information. You're going to get the mean, the standard deviation, which gives you a sense of the center for each column's values, as well as how widely dispersed it is. You're also going to get the 5-number summary, the minimum, maximum, 25th percentile, 75th percentile, and 50th percentile, which is the median. And so then you're asked to find any columns where there are noticeably large gaps between the 75th percentile and the maximum value. And so just looking through here, we see here it's double the 75th percentile. Here it's more than 3 times as great. Here it's like 6 times as great. Here it's like 6, 7 times as great. Here it's certainly, it's whatever, it's 7 times as great again. And so a couple of these, you find a much bigger spread than in others. So you could identify the free sulfur dioxide as a large gap proportionally, chlorides, residual sugar, and those are the largest. And so you could identify those columns. And again, what we're talking about is, let's say, the ratio of the maximum to the 75th percentile, not the difference, because since these are scaled so differently, we want to look at something that basically takes into account the fact that scales are going to be different. Okay, and then you want to know which has the greatest variability, and for that we're going to take a look at the mean and the standard deviation. So what we're looking to see is in which case is the standard deviation, which is a measure of the distance from the mean on average of the values, how big is that in comparison to the mean? So if we scroll across here, we can see, so for example, for sulfur dioxide, the standard deviation is half as large as the mean, and that's almost true for the chlorides. Residual sugar, it's actually much bigger than half. And so as we scroll across here, we can see that that looks like it is going to be the largest proportionally. In other words, the distance from the mean on average for the values in this data set are larger for residual sugar than is the case in the other quantitative values. Okay, you're then asked for the range of values and in the quality column, and so it's asking you where do the most of the values lie. Well, when we look at the 5-number summary here, we can see that for quality, the minimum is 3, the maximum is 9, and 50% of the values are between 5 and 6. So we know that, certainly between, let's say, 4 and 7, you're going to end up with more than half the values. We know that, again, we get half the values just between 5 and 6. So that means it's very closely clustered toward the middle of the range. And again, the range goes from 3 to 9. Nothing's below 3, nothing is above 9. Okay, so then you're asked to use these measures here, BX box and BX histograph. And so what you're looking at is you're looking at the shape of the box plot and of the histogram, and you're just describing, does it look like it's roughly normal in shape, which is to say, does it have that sort of bell shape to it? Or does it look like there's a tail extending to the right or extending to the left? So just take note of what shape you see, both in the box plot as well as the histogram. The box plot you can look at, does it look roughly symmetrical? Is one part of the box much more scrunched up than the other half of the box? Is one of the whiskers, as the two horizontal lines on either side of the box are called, is one much longer than the other? Are there outliers indicated by individual points on one side, on the high side? Are there outliers on the low side? So make note of that. That's what this question is asking you. Okay, the next one is asking you to run this code, and what you're going to see is you're going to get the histogram, but you're also going to get it a box plot alongside of it. And so that actually is helpful to be able to see both of those, because each of them give you slightly different information, and to have them together on the same horizontal scale makes it that much more useful. Okay, so the response variable in this case is the quality. So we're trying to figure out which of these chemical properties correlate most highly with the quality. In other words, which of them seems to be either as it goes up, the quality goes up, or as it goes down, the quality goes down. And so when we run this df.core, we get a matrix, which is to say a table that shows you the columns and the rows representing each of the different values. And what you'll see is that going down the diagonal, you'll see that each of the values, the different columns, correlates perfectly with itself, which is not surprising. As the alcohol level goes up, the alcohol level goes up perfectly. So that doesn't tell us very much. But when you look at some of the other values, let's say you look at the relationship between alcohol level and quality, is that number between 0 and 1, or is it between 0 and -1? If it's between 0 and 1, it means that as the alcohol content goes up, the quality goes up. Is that number very close to 0? Or is it closer to 1? Or is it somewhere in between? The closer it is to 1, the stronger the correlation. When it's very close to 0, it means that there's really not much correlation at all. In other words, what happens with the alcohol content doesn't really correlate with what happens with the alcohol level. They move kind of independent of each other. And so you're looking for the values that have the highest, for quality, the highest positive value and the highest negative value, which is to say the negative value with the highest absolute value. And those would be the two things that correlate most strongly in either a positive direction if the value is positive, or a negative direction if it's negative. Again, if the correlation is negative, it means that as that particular value goes up, the quality tends to go down. Okay. The heat map just really shows you visually what that df.core shows you in a tabular format. And so again, you can look at the color chart to see what colors indicate higher or lower correlations, closer to 0, more negative, more positive, and that will just basically give you more of a visual overview of the relationship between the different variables. And then you're going to look at two of the variables in particular, alcohol and quality, and you're going to look at a scatter plot, and you're going to see this is now a dot for each of the 4,898 different wines. And as you look at that, does it look like the relationship is roughly linear? Is it positive? Is it negative? And that'll tell you something about, that'll give you additional information about the relationship between these two variables. And one of the things you'll notice are these horizontal lines, and the idea there is that the horizontal lines occur because there really aren't any values between, let's say, 2 and 3 or 3 and 4. So all of the dots are going to align along the same horizontal lines, either 2, 3, 4, 5, 6, etc., rather than being scattered all over the place as they are for the x variable, because the x variable, or the alcohol, is a float, not an integer. Okay, then after you put in the trend line, you're going to see that's the line of best fit. And so if you get the hover right on the trend line, you'll get the equation of the line of best fit. And what we're saying is that the quality equals some number, some coefficient, times the alcohol level plus some value. So it's a y equals mx plus b format for the equation. And what this is saying is that every time, whatever the value of that coefficient is, multiplying the alcohol level, it says that whenever alcohol goes up by 1 unit, quality goes up by whatever the coefficient is for that. So if the coefficient was 0.25, it would say that every time the alcohol level went up by 1 unit, the quality would go up by, on average, 0.25 points. The R-squared value is telling you, it's taking that the correlation number that we saw before, it's squaring it, so it's always going to be positive. And what this is telling us is that as we see the variation in quality, how much of that variation is explained by the variation in alcohol. If that number R-squared is very close to 1, it means that 100% or nearly 100% of the variation in the quality level is explained by variation in the alcohol level. If that number is very close to 0, it means that very little of the variation in the in the quality level is explained by the level of alcohol. Generally, we would expect something in between. And so that is going to tell you what percentage of that variation is explained by the alcohol, by the variation in the alcohol.